This section of the report talks about the kind of technology your project uses and how do they compare with other systems. This is an attempt to justify why you chose your project and why you selected the components to complete your solution. For example, there are many ways to measure temperature. One method of measuring temperature is to use LDR and detect the light, and maybe the light will change depending upon the temperature. Or maybe you can measure the weight, and as the temperature changes, the weight changes. Basically, I'm trying to get you to understand that there are different techniques, and that's the word technology comes from. It comes from the technique that's being used to complete a job. We are able to operate things without wires, but what technique do you use to send the information? Do you use radio waves? Do you use infrared, or do you use light? What is your technique, or what technology? There are very common words out there, including optical, nanotechnology, alternative energy. Depends on what the application is to what words you use. Well, one thing in common is that your system will be using digital control systems. That's not the only way to control a process. You can control it using analog circuits, combination of amplifiers and digital circuits put together, counters, timers. But I believe we have agreed that microcontroller-based systems is a good foundation for most electronic solutions nowadays. So at the foundation of most systems is the microcontroller. And there are several different versions of the microcontroller to choose from. Different levels, different capacities. Some of you may be using the 8051, which uses a type of processor. And some of you might be using the basic stamp, which is another technique for dealing. The basic stamp may be easier to use and easier to program, but you lose a lot of capacity because a lot of the work has been done for you. Whereas with the 8051, you have to start from the ground zero level and build your way back up. It takes a lot longer to develop the programs, but at least you understand every single step of how your system works. So it's the difference between building a house from the ground up or going to a builder and let the builder design something based on your criteria. So what technique did you use? In this system, we're using a temperature sensor, and we're also using a motion sensor. As some of you have learned now, if you do an internet search on these two components and you type in temperature sensor, you will get 1,000 links as well as motion sensor. So you have begun to learn that there are many techniques to measure temperature and there are many techniques to detect motion. So you have to explain a little bit about how this component is measuring temperature and how this component measures motion. What is the technology? Also, you have some signal conditioning circuits, analog to digital converter, amplifiers, and once again, there are many types of amplifiers and digital signal converters. There are 8 bits. There are 12 bits, as you know. So which one did you use and why did you choose it? There are many types of amplifiers. You could use a transistor-based amplifier or an op-amp or a transformer, step-up transformer to amplify voltage. So which technique did you use to do the job? So you must try to explain. In my project, I used a serial analog digital converter because I wanted to reduce the number of wires and reduce the size of the chip. I selected a motion sensor called PIR, which really detects the heat. It uses body's heat to detect motion. So if there's a change in temperature in the room, it actually detects the change in temperature to recognize motion. Here is some type of material that reacts to temperature and it creates a mini voltage, like a piezo. So there's a technique that this designer used to create my temperature sensor. On this side, for my lamps, I have many techniques to operate my lamp. I could try and connect the lamp to the mic controller, but that's not possible because the microcontroller does not have enough current. So I need to find another way to give current to this lamp. And I can give it using a BJT transistor or a MOSFET transistor or a relay coil or many other different ways. But in my design, I'm using a MOSFET to reduce the amount of current needed by the microcontroller. And I'm not really thinking about speed, so I've decided a MOSFET. Same thing with the fan. Fan is a motor, and you may have to think about how to switch the fan on and off to reduce the noise from the motor. So again, I have to explain how am I turning the fan and what technology, what technique am I using to deal with it? Am I using serial? Am I using parallel? Am I using nanotechnology? Am I using optical or radio frequency? Some of your projects have wireless, so you're using radio signals. That's a technology. Now, does your project compare with other systems? How does it compare? Well, we can just say that this project is a standard lighting control system or temperature control system found in most office buildings. And the idea of the project is to lower the energy, save energy. And the components here are very easy to find in any electronic shops, and it can be produced at a reasonable price. And it may not be competitive, but the fact that you can produce this within your own country, you might be able to save on export costs. And it can easily be developed by UAE citizens graduating from ACT from all their practical experience. So this is within your range, in your ability to do. There's not too many new systems that's going to be able to be done at this level, but you can at least justify or explain the technology that's being used in your system. And you can compare your system with other systems on the internet and decide whether or not it's using a new approach or whether it's targeting a specific customer. Thank you.